Okay, in an earlier video, we saw how to make a map like this one of the topographic surface at a hypothetical site. And so we're going to build on that by looking at how to do some arithmetic with these grid files. So what I'm going to do is go back to the data file and select the same data file, and I'm going to make a map. Instead of the ground elevation, I'm going to make a map of the depth to water, and I'm going to change the name so I can keep track of what this file has in it, depth to water. And I need to make sure to change the max and min values to those same values that I used before. Okay, 700 by 700. So then I hit OK. And I make a new grid file. And so I can take a look at it. There it is. And that's what it looks like. Okay, so I don't really care too much about having a map that shows me the depth to water, but what I do care about is a map that shows me the hydraulic head. And I can get that by taking the ground surface and subtracting off of it the depth to the water. So what I want to do is take this map and subtract this map. And so what will happen when I do that is I have a grid that's been created, and actually I can show you the pattern that looks like that. If we go down here to Grid Node Editor, let's take a look at depth to water. Here's the contour map, and here are all the locations where I have values at this grid, and I can click on that, and there's the value at that location. So this grid file, this .grd file, has this many numbers in it. And what I'm going to do is go through this grid, and at each location, at every location where there's a number here, there's also a number here. So I can do an operation that will subtract this grid, and we'll take this grid and subtract from it this grid and create a new file, a new grid file. And to do that, I'll use math. So this is arithmetic that is applied to these grids. So we'll first do ground elevation, and that'll be the grid file A. And then we'll do depth to water, and output will be a file that we'll call piezo for the piezometric surface. Piezo. And so this will be file A, this is B, and this is C. And so we can write an equation where file C is equal to file A minus file B. And what this will do is create a grid file that has the same dimensions as A and B, the A and B files, and at each location it will have a value that is the value of A at that location minus the value in the B file. So we hit that, and we create this file called piezo, and we can go ahead and take a look at that. There it is. And so there's the map that is the piezometric surface, and you can see we've got regions here where the gradient is fairly uniform, and then here is a place where there's some kind of anomaly, probably a well. And we can do the same kind of things that we've been doing. We can change the colors here. So let's do something like that. And let's see, we might in this case be interested in a vector map. This is hydraulic head, so the flow will be perpendicular to the contours. And there's a map of there are the gradients. but we see that, let's see, this is high and that's low, so these are pointing uphill, and that's what we expect for the gradient. But if we wanted to have a map that shows the flow, we would want to have it be, we're going to uncheck this box, and now here is, this is going to be in the opposite direction of the gradient, and this is showing the direction of flow, and we'll superimpose these using map overlay. And so there's these vectors that are perpendicular to the contours, and we see kind of regional flow here, and then flow that converges on this location right here. Okay, so map arithmetic, this is a fairly simple example, but this will give us a great deal of flexibility in what we can do, where we create maps and then use different maps in different ways, where we manipulate different maps to give us additional insights into what's happening.